Welcome to the Tech Egg. Don't get scrambled. Enjoy the video.
You begin by adding the essentials so you can apply the Cpm35 filter immediately. Open your Android Studio project, update Gradle and SDK to supported versions, and add any native modules if the filter requires JNI. Once done, include the Cpm35 dependency or source file in your app module and grant camera and storage permissions. Make sure to target the proper ABI and enable debug logs so you can verify the filter loads. This prepares the build and runtime environment for the next steps. Now you wire the Cpm35 filter into your processing chain. You import the filter implementation or shader, then attach it to the camera preview or bitmap pipeline. For surface-based rendering, create a GL texture and bind the filter program. Tune parameters like intensity and radius by exposing setters that you can tweak live. This matters because Cpm35 relies on those values to balance contrast and detail. While executing, log intermediate frames and use breakpoints so you can verify visual output and performance in real time. Finish by validating the Cpm35 filter across devices and edge cases. You should run end-to-end tests on various resolutions and lighting, profile CPU/GPU usage, and fall back to a simpler path for low-end devices. Once done, package the APK and verify image quality in release mode. If things go wrong, make sure to check runtime logs, confirm camera/storage permissions, and verify native library ABIs match the device. This single troubleshooting step catches most integration issues quickly and gets you back on track.
Thanks for watching. Consider subscribing if I helped unscramble your problems.